All right, so are you ready to dive deep? Today, we're tackling something that you specifically requested.
Oh, this should be fun.
Right. The mind-bending idea that physics is a kind of language.
Okay, I'm intrigued already.
We're going to be pulling from a chapter, actually, that's titled, you guessed it, Physics is a Kind of Language. And let me tell you, it gets wild.
Well, it is a fascinating premise. If the universe operates like a language, right? Then what are the words? What's the grammar?
The syntax, even.
Exactly.
And to help us unpack all this, we've got some heavy hitters, some serious thinkers we're going to be looking at. Stuart Kauffman,
Ah, yes. The complexity theory guru.
that's the one. And of course, Claude Shannon.
Well, you can't talk information theory without Shannon. He's like the father of it.
Exactly.
Yeah.
And listen, no deep dive into physics would be complete without at least a little sprinkle of, Einstein.
Boltzmann, of course.
Naturally. Gotta have Boltzmann.
What's fascinating to me is how all these different fields, wartime code breaking to the study of entropy, they all start to connect when you view the universe through this lens of language.
And speaking of code breaking,
Yeah.
this chapter kicks off with this captivating historical anecdote about how World War II really, it basically forced the rapid development of information technology.
It's remarkable how intense pressure, can lead to breakthroughs. Like, imagine without the urgency of deciphering Nazi codes at Bletchley Park,
Oh, wow.
we might be decades behind in computing power.
It really makes you think, if Alan Turing and his team, if they hadn't been pushed to their absolute limits, would we even have smartphones today?
It just highlights how scientific progress isn't always a straight line.
Right.
There are these influences, these historical events, even societal pressures that can really shape things.
Totally. But before Turing could, crack codes with computers, the groundwork had to be laid. So this chapter gives a shout out to, well, some less known figures who were instrumental. People like, well, there's Alfred North Whitehead
Of course, Bertrand Russell, can't forget him.
and Max Newman.
Their contributions, to logic, mathematics were absolutely crucial to what came later. It's a reminder that progress, well, it's often built upon the work of those who came before, even if their names aren't widely recognized.
Right, exactly. Okay, so from wartime code breaking, the chapter takes us on a seemingly sharp turn
Okay, where are we going?
into the world of thermodynamics.
All right. Entropy, disorder, all that jazz.
You got it. So can you give us a little refresher? What is thermodynamics really about?
It's all about energy, how it flows, how it transforms within systems, and entropy. Well, entropy is this measure of, disorder, randomness. Think of it like your room.
Okay.
It naturally tends towards messiness unless you put in energy to tidy up. Right. That's entropy at work.
So the second law of thermodynamics basically says that in a closed system, like the universe, things inevitably become more disordered over time.
Yeah.
Like, left to its own devices, everything would eventually just fall apart.
Well, that's the classical view, but here's where it gets really interesting.
Okay, wait on me.
If entropy always wins, right? How do we explain the existence of stars, planets?
And life itself.
Exactly. These are incredibly complex, organized structures in a universe supposedly destined for chaos. Think about it. It's like finding a perfectly built Lego castle in a room full of scattered bricks.
Oh, that's a fantastic analogy. And that's where Stuart Kauffman comes in, right? With his work on complexity theory.
You got it. Kauffman, he showed that systems can actually evolve from disorder to order. Think about it. Your body's cells, they take in energy, they form complex structures, even though entropy, you'd think, would suggest that they should just be falling apart.
It's like defying the odds. So does this mean that the second law of thermodynamics is wrong?
Not necessarily. Kauffman, he proposed a fourth law of thermodynamics to try to account for this spontaneous order. He argued that there's this inherent drive towards complexity in the universe, a force that counteracts entropy's pull towards disorder.
So we've got information theory, we've got thermodynamics, and we've got complexity theory all kind of swirling together here. Now, this chapter brings us back to Claude Shannon and his focus on the role of difference in transmitting information.
Well, Shannon's work, it was revolutionary. He demonstrated that difference is, well, it's crucial for conveying information. Just think about it. If every letter in the alphabet looked the same, you wouldn't be able to read this. You need those distinct signals, those differences, to understand any message.
That makes perfect sense. But if difference is so crucial, why didn't Shannon consider the role of well, similarity. I mean, they seem like two sides of the same coin. You can't have one without the other.
Now that is a great observation, and it's something this chapter really explores in depth.
Okay, I'm hooked. Tell me more.
The chapter suggests that just like difference is essential to transmit information, so too is its mirror image, similarity. Think about, those CAPI-TCHA tests you get online.
I hate those.
Right, where you have to like identify all the images with, say, streetlights. You're recognizing both the unique traits of a streetlight and how they're similar to each other to distinguish them from, I don't know, a stop sign.
Oh, that's a really good point.
Yeah.
It makes me wonder how this whole idea of difference and similarity, how does that play out on like the grand scale, like the universe?
That's where things get really fascinating. This chapter argues that even space, like the space around us, it's not just this empty container for stuff to exist in. It's actually defined by the relationships between objects, and those relationships, well, they're all about difference and dissimilarity.
So instead of thinking of space as this static backdrop, we should be seeing it as something dynamic, like shaped by the interplay of objects.
Exactly. Consider, just as a simple example, two planets. The distance between them, that's a measure of difference. But they're also both subject to the same laws of physics. That's a fundamental similarity.
Right.
Space isn't just this stage, It's an active participant in this cosmic dance of relationships.
Wow, that's a cool way to visualize it. And if space is part of this dance, where does time fit in?
The chapter suggests that time is essentially, it's a measure of change, a way to track how those relationships between objects, how they evolve. Think about a photograph. It captures a specific arrangement of objects at a moment in time, but as those objects move, interact, the relationships change.
And time flows forward.
Exactly. Time is the language the universe uses to tell its story. A story where difference and similarity, well, they're the main characters, constantly interacting is shaping the narrative.
So we've zoomed out to this cosmic scale, right? But what about zooming in, like to the microscopic level? Particles. Does this idea of difference and similarity hold up there?
Oh, that's where things get really mind-bending. Quantum mechanics, it completely revolutionizes our understanding of these concepts. In the quantum world, particles, they don't always have definite properties.
Wait, what do you mean?
It's like they exist in this blurry state of potentiality. Imagine a spinning coin before it lands on, heads or tails.
Okay, yeah.
It's both, potentially, until that moment of observation. That's kind of how quantum particles behave. They embody multiple possibilities, both different and similar at the same time, until, that is, an interaction forces them to, choose a specific state.
Whoa, so it's like the act of observation itself plays a role in shaping reality at the quantum level.
Exactly. And it gets even weirder, trust me. There's this phenomenon called entanglement. It's where two particles, even separated by vast distances, become linked.
Okay.
They share a fate, even though they're physically apart. It's like they're communicating through some hidden channel that, I don't know, transcends our usual notions of space and time.
Okay, that's mind-blowing for sure.
Yeah.
So from the tiniest particles to the largest structures, it's this interplay of difference and similarity that really defines reality.
Precisely. The chapter emphasizes that this view, of the universe as this network of relationships, it's really at the heart of modern physics. It's a unifying theme connecting things like relativity, quantum mechanics, even cosmology.
So are we saying that difference and similarity are more fundamental than space, time, and matter?
Now, that's a profound question that physicists are still grappling with, to be honest.
Yeah.
But this chapter suggests that these concepts are they're deeply woven into the very fabric of reality. It's amazing to think that something so simple as difference and similarity could be so fundamental to the universe. And it raises even bigger questions about, well, consciousness, the meaning of life, even our perception of reality itself. Okay, so I'm with you so far, but there's one piece of this that's still kind of bugging me. We've talked about information, relationships, the language of the universe, but where does meaning fit into all of this?
That's an excellent question, and it's something the chapter, it tackles head on. Remember how we were discussing Shannon's decision to exclude meaning from his definition of information?
Yeah, he was focused on those technical aspects, not on what the information actually signified.
Right.
But while that was super useful for communication theory, the chapter makes the case that, you can't ignore meaning if you really want to grasp the universe's language.
So how do we bring meaning back into the picture then?
The chapter suggests that meaning, it arises from this very interplay of difference and similarity, from the way those relationships connect and shape our understanding. Think back to the analogy of the universe as a sentence.
Okay, I remember that.
A sentence is more than just a jumble of words. It's the relationships between those words, the grammar, the syntax, that give it meaning.
So it's not just about the individual bits of information, but like how they fit together, how they relate to create a larger picture.
Exactly. And that's where our human minds come in, you know? We're not just passive observers of this. We actively participate in creating meaning by interpreting those patterns, those relationships in the universe's language.
It's like we're constantly trying to translate this cosmic code to figure out like what it all means.
Exactly. And just like learning any language, our understanding evolves over time. The more we learn about the universe, the more nuanced our interpretations become. It's this continuous dialogue between us and the cosmos.
Okay, so meaning emerges from this interplay of difference and similarity. But where do we go from there? Like, how do we actually make sense of all this?
Well, the chapter brings in this fascinating concept of interpretation.
Interpretation, like how we interpret a book or a work of art.
Exactly. We're constantly interpreting the universe, trying to decipher the patterns and connections we see. You know, it's not enough to just acknowledge that difference and similarity are at play. We have to actively engage with them, try to understand what they're telling us.
So it's like the universe is speaking to us in this language of relationships. And it's up to us to learn how to listen and interpret what it's saying.
That's the heart of it. And that interpretation, it's not a one-time thing. It's an ongoing process, a constant back and forth between us and the universe. As we learn more, our interpretations evolve, become more, I don't know, sophisticated, complex. It's like we're refining our understanding of this cosmic language with every new discovery.
This is blowing my mind wide open. It's like everything is connected and everything has meaning.
That's the beauty of exploring these deep connections. It can lead us to this profound sense of awe, of wonder at this intricate web of existence.
Okay, so we've covered how difference and similarity, they shape space, time, even the quantum world. But this chapter keeps coming back to this idea of physics and language being linked. We've talked about the universe having a language, but what does it actually mean to say that physics is a kind of language?
That gets to the core of what this chapter is trying to get across, It's not just about finding poetic analogies or metaphors between physics and language. It's about recognizing a fundamental connection.
Okay, so there's a real concrete link.
Exactly. Both physics and language, they're ultimately systems of representation.
Yeah.
They're tools that allow us to describe relationships.
So just like physics uses equations to describe the relationships between forces, language uses words to describe the relationships between ideas.
Precisely. They both create a map of the world, a way to understand, to navigate reality. But they're not just passive systems of representation, right? They actively shape how we perceive and interact with reality.
Absolutely. The language we use, it can influence our thoughts, and those thoughts shape how we understand physics. It's this amazing feedback loop. So it's not just that physics is a kind of language, but that physics and language are constantly co-evolving, each shaping the other in this dance of meaning.
That's a beautiful way to put it. And it highlights, the interconnectedness of all knowledge.
If physics is a kind of language, does that mean like the universe is literally a giant book waiting to be read? Are we just trying to decipher its pages?
That's a question that's captivated, humans for millennia. And while the chapter doesn't offer any concrete answers, it does give us some interesting things to think about.
Okay, what kind of clues are we talking about?
It highlights how the universe is, it's constantly evolving, creating new patterns and relationships, all the time.
So it's not like there's a fixed script or blueprint.
Right. The story is being written as we go. The universe is improvising, constantly generating new possibilities. The speaker of this language isn't some static entity, but rather the dynamic process of the universe itself.
It's like the universe is this incredible jazz musician, riffing, creating new melodies as it goes along.
I love that.
And we're all part of the band.
And that opens up this incredible possibility that we're not just passive listeners to this cosmic music. We're active participants in its creation.
Our thoughts, our actions, even our very existence, it all contributes to the evolution of the universe's language.
That's a powerful idea, isn't it? It suggests that we're not just, insignificant specks in this vast cosmos, but co-creators of reality.
Wow. This is making me rethink my entire place in the grand scheme of things. It's humbling, but also, like, really empowering.
Absolutely. And that realization, well, it can change how we approach everything, from our personal lives to our role in society. Okay, so we've explored this idea of the universe as a language, difference, and similarity, the emergence of meaning, the role of consciousness. We've even pondered, like, who or what might be speaking this cosmic language.
That is a lot to digest.
Right.
But there's one final thought I want to leave you with.
Oh, I'm intrigued.
If the universe really is a language, what does that say about the limits of our understanding? Are there parts of the universe that are just beyond our comprehension, like trying to read a book in a language we've never learned?
That's a really profound question, and it touches on this inherent mystery of existence. While science has, made incredible strides in unlocking the universe's secrets, there will always be questions that remain unanswered.
So it's not just a matter of time before we figure everything out. There might be, like, fundamental limits to what we can know.
That's a possibility we have to be open to. Our human minds, as amazing as they are, they might just not be equipped to grasp certain aspects of reality. It's like trying to, I don't know, explain calculus to a toddler. The concepts are just too complex for their level of development.
It's humbling to think that there might be entire levels of reality that are just, like, beyond our current cognitive abilities.
It is humbling, but it's also incredibly exciting. I mean, it means there's still so much out there to discover, so much wonder left to explore. Instead of being discouraged by what we don't know, we should be inspired to keep pushing those boundaries of knowledge.
So we should embrace the mystery, keep asking questions, even if we don't know if we'll ever find all the answers.
Absolutely. The pursuit of knowledge, it's a journey, not a destination.
Right.
And the unknown, well, that's what makes that journey so captivating. This whole conversation has been a real mind stretcher. It's made me realize that the universe is far more complex and mysterious than I ever imagined.
And that's the beauty of it, right? There's always more to learn, more connections to discover, more layers of meaning to uncover. So as we wrap up this deep dive into this fascinating intersection of physics and information, I want to encourage you to keep exploring, keep asking those questions, and never lose that sense of wonder.
The universe is this vast and intricate tapestry, and we're all part of its ongoing story. Let's keep weaving that story together, thread by thread, question by question, discovery by discovery.
It's like we're all characters in this grand cosmic novel, and we're just starting to understand, the plot. Maybe even learning to write our own chapters along the way.
That's a beautiful way to think about it. We're not just reading the universe's story. We're contributing to it through our choices, through our actions.
This whole idea of physics as a language,
Yeah.
I mean, it's really shifted my perspective. It's like the universe is suddenly just, like, brimming with meaning and purpose, even in things that seemed random or chaotic before.
It's all about recognizing those connections, seeing the underlying unity beneath all the apparent diversity. That's where the true beauty lies.
Okay, so we've explored, like, these deep philosophical implications of this idea that physics is a kind of language. But let's bring it back down to earth for a minute. How did this understanding actually impact our lives, our day-to-day reality?
That's a great question. The chapter touches on that in its closing remarks. It argues that this perspective, this way of seeing things, it can fundamentally change how we approach science, technology, even our relationships with each other.
Okay, I'm all ears. Let's start with science. How does seeing physics as a language, how does that change the way we actually do science?
It encourages us to move beyond reductionism, to look beyond just breaking things down into their smallest parts. Instead, it pushes us to see the interconnectedness of different fields, how they all weave together to form a larger picture.
So instead of studying things in isolation, we should be looking for the connections, those underlying patterns that unite different disciplines.
Exactly. It's like seeing the forest for the trees. Suddenly you realize that biology, chemistry, physics, they're not like separate subjects. They're different dialects of the same language.
And that language is the language of the universe.
Mm.
By understanding its grammar and syntax, we can gain a much deeper appreciation for the complexity, the beauty of the natural world.
Precisely. It's like learning to read, to really read the universe's poetry.
Okay, so that's science. What about technology? How does this perspective, this new way of thinking, how does it change our relationship with technology?
It encourages us to develop technologies that are, well, that are in harmony with the natural world, technologies that work with the grain of the universe's language, not against it.
So instead of trying to, like, force nature to conform to our will, we should be trying to understand its principles and like, collaborate with them.
Exactly. It's about moving from a mindset of domination to a mindset of partnership. We need to recognize that we're part of a larger ecosystem, and our technologies, well, they should reflect the understanding.
By learning the universe's language, we can create technologies that are not only more sustainable, more efficient, but also just, like, more beneficial to both humanity and the planet.
Precisely. We can use our knowledge to create a future where technology and nature, well, they exist in this symbiotic relationship, each enhancing the other.
Okay, so we've talked about science, technology, but what about our relationships with each other? How does seeing physics as a language, how does it influence how we interact with other people?
It reminds us that we're all part of this same interconnected web, speaking different dialects of the same universal language. It highlights the shared humanity that binds us together.
So instead of focusing on our differences, we should be looking for the common ground, the shared experiences that unite us.
Exactly. It's about recognizing that we're all characters in the same story, all contributing to the ongoing evolution of the universe's language.
And realizing that, and that can lead to greater empathy, compassion, understanding.
Absolutely. When we shift our perspective from one of separation to one of interconnectedness, we start to see the world and each other in a whole new light.
This whole conversation has been incredibly inspiring. It feels like a call to action, an invitation to live more consciously, more purposefully.
And to use our understanding of the universe's language to create a more beautiful, harmonious, and meaningful world for ourselves and future generations.
Well, folks, we've reached the end of our deep dive into this fascinating world where physics meets information. We've explored this mind-bending idea that the universe itself might be a kind of language, network of relationships that we're just beginning to decipher.
We've explored the profound implications of this perspective for science, for technology, and for our relationships with each other. We've even glimpsed the breathtaking mystery and wonder that lie at the very heart of existence.
And as we conclude this deep dive, we want to encourage you to keep exploring these ideas, keep asking questions, keep searching for those connections, and never lose that sense of wonder. Who knows what incredible discoveries await us as we continue to learn the language of the universe. Until next time, keep those minds open and your curiosity burning bright.